हाँ हाँ मैम, अभी तक कुछ बोला ही नहीं मैंने. Okay. So what we have done till now is about Laplace transform. हम लोग ने उसका definition देखा है अब तक, बेसिक प्रॉपर्टीज देखी है, स्टैंडर्ड फंक्शन के लाप्लास देखे थे. लास्ट क्लास में दो इंपॉर्टेंट चीजें की थी, एक था लैप्लास ऑफ डेरिवेटिव, दूसरा था कन्वोल्यूशन थ्योरम के बारे में हमने जाना था लैप्लास के लिए. इन दिस क्लास वी विल बी स्टार्टिंग विद इंटीग्रल इक्वेशंस. इंटीग्रल इक्वेशंस यानी कि वी वांट टू सॉल्व एन इक्वेशन in which there is an integration of a function, right? So an equation in which the unknown function occurs under an integration would be called as an integral equation. बहुत ही simple सा definition है. An equation of the form like this. Integral equation जो हम लोग study करने वाले हैं, that is going to be a particular case of this, but the integral equation in general is of this form. We need to find out this f of t. Our aim is to find out this f of t, where this h of this constant lambda is given, this limits are known to us, this is called as a kernel function, this is also given, and the same f is over here but in terms of the variable tau. So it is f of t is equal to h of t plus lambda integration a to b kernel function, which is in terms of t and tau, f of tau d tau. This kind of an equation would be called as an integral equation, where our aim is to find out f of t. The most important thing that I would tell is the name of this equation, right? I'll just highlight the name. This equation is called as a linear integral equation of second kind. Also you can call it as a linear volta. Now it might be possible कि नाम को क्यों इतना importance दिया जा रहा है. The only reason is one of the set examination, I think previous to previous year, they have asked only the name of the equation. They have given it and they have asked what is the name of this equation. So it is nothing but linear integral equation of second kind. और इसके साथ और एक word है जो add होगा वो बाद में देखेंगे. But for now, what is the integral equation? Any equation of this form would be called as an integral equation where f of t is unknown that we need to find out. Okay. वो हियर ये अगर कर्नल जो है अगर वो किसी स्पेशल टाइप का हो जाता है उसके साथ साथ लिमिट a और b, if they are also of special type, we get a particular case of this integral equation. If where this is called as a kernel, if the kernel of the equation is of the form gt minus tau, then this integral equation would be called as a convolution integral equation and it would be of this form. So if you recall, in the previous class हम लोग ने ये देखा था ना कि f convolution g at the variable t is given by integrating 0 to t f of t minus tau g of tau d tau, and there were few properties of convolution that we have discussed. By the name convolution, that should be clear because here we have the convolution of f and g. This is nothing but convolution of g and f at variable t. Now in our this course, that is set theory, set के लिए जो हम लोग prepare कर रहे हैं, in that the only thing that we require is to solve such a convolution integral equation by using Laplace transform. ठीक है, तो हमारा काम होगा इस इंटीग्रल इक्वेशन को Laplace का यूज करके सॉल्व करना. Solving an integral equation, that means finding out the value of f of t. Is it okay till now? I think I forgot something, that is to join. Okay, ma'am है तो reply कर देंगे. ठीक है, okay. So what we do is just start learning how to solve such kind of equation. Okay. So few of the basic of the previous class would be required definitely. Let's see कितना को याद है. So I need to solve the following convolution integral equation. We would be using the Laplace transform. Before I start applying Laplace transform, I can write the given equation as f of t is equal to h of t lambda plus lambda times convolution of g of t with f of t. So first of all I converted into convolution. Now applying the Laplace transform, हर एक फंक्शन का जो Laplace होगा मैं उसको उसके कैपिटल से डिनोट करूंगा. That means if I apply the Laplace transform, then f of t will become f of s. That means f of s is nothing but Laplace transform of f of t. So similarly this is the Since it is a transform, that means it is linear, so I have plus lambda. What would be the Laplace transform of this? F of t, g of t. Okay, yes. What would be the Laplace transform of the convolution? Yes, anybody? What I do, I just join through uh, my phone as well, so I can see the chat box. Yes, but anybody, what would be the Laplace transform of convolution of g of t with f of t? Yeah, ma'am. Yes, it is lecture 2. Same link I have to use. I cannot see the chat box yet because I haven't joined. I just joined through chat box.
Laplace transformation of f into Laplace transformation.
That means I can write it as f of s g of s, right, Mandar?
Yes, sir.
Okay. So now what we want, we just simplify it for f of s. So I get it as f of s minus lambda times f of s g of s is equal to h of s. That is same as my f of s can be written as h of s divided by 1 minus lambda g of s. We here from this to this we have used the convolution theorem. That means convolution इसी तरीके से define किया था such that after applying the Laplace we get the answer as a product of the Laplace individually. Right? So what was our aim? Our aim was to find out this f of t. Now the Laplace of f of t is capital F of s. I want to go reverse way. That means to find out my f of t, that would be same as the Laplace inverse. That would be Laplace inverse of capital F of s. Oh, that is same as Laplace inverse of h of s upon 1 minus lambda g of s. So what we are learning is we are just trying to learn how to solve a convolution integral equation by using a Laplace transform. So means if you want to find out a solution of this equation, that is nothing but a Laplace inverse of h of s upon 1 minus lambda g of s, where h of s is nothing but Laplace of the function over here and g of s is nothing but the Laplace of function over here. Is it okay? I just request to just note down this slide because this is one of the important things. लास्ट 4 साल में से 2 साल तो उन्होंने लाप्लास यूज करके कन्वोल्यूशन इंटीग्रल सॉल्व करने के ऊपर क्वेश्चन पूछा. So this is one of the interesting question they find. If you are done writing, please let me know in the chat box. We will be solving a basic problem from the reference book and also one of the problem from previous year paper and one problem I will leave as an exercise. Just try to understand any step anywhere. If there is some question, please ask. Do let me know if it is done. Yes. Yep. Okay. So let's go to the revision, right? Because whenever we want to go for Laplace, this formula should be there with us. So just for a few seconds, I'll keep it on a screen because we will be using it. 1 का Laplace 1 by s e raised to at का Laplace 1 by s minus a sin at formula cos at. All the formulas are necessary for any examination जहाँ पे integral transform पूछा जाने वाला, right? So these are nothing but the same slide that I have wrote earlier. Just for a few seconds, go through it once. Okay. Okay. We'll see it again if it is required. Okay. So now we will be solving this integral equation. So what we have learned, let us just try to write it in a 2 lines. What I have learned, suppose if I have equation f of t is equal to h of t plus lambda times integration 0 to t g of t minus tau f of tau d tau. then the solution of this is nothing but Laplace inverse of h of s upon 1 minus I don't know. Okay, I'll just see that later on. Sure. Okay, so this is 1 minus sorry, it was a call from somewhere. Okay, so it is g of s times lambda converted to t. So if I want to find out the solution of this, then I need to find out the Laplace inverse of h of s. So what is my small h of t? I'll just note. This is my small h of t. Where here I have constant 1 multiplied. So this is my g of t actually. So what is a Laplace of a? What would be the Laplace of a? Just let me know in the chat box. Laplace transform of a. It is one of the easy formula, right? What was the Laplace for 1? Laplace for 1 was? It was 1 by s, so it should be a by s. So my h of s is nothing but a by s divided by 1 minus lambda is over here, so it is 1 minus lambda. My g of s, my small g of t is 1, so the Laplace would be 1 by s. I need to find the Laplace inverse of this. So that is same as Laplace inverse of, I can write this is same as a divided by s minus lambda converted to variable t. So can you guess a function जिसका Laplace ये था? Yes. ऐसा कौन सा फंक्शन था such that उसका Laplace आता था 1 by s minus a? Yes, it was e raised to at. So it is, if it is e raised to at, what should be my answer over here? First of all, this a, the numerator is constant, I take it outside. So inside the bracket I have 1 upon s minus lambda. So here the replaced by lambda, so there's nothing but e raised to lambda t. Correct. So the solution of this easiest integral equation is nothing but 8 times e raised to lambda t. This is a function which satisfies the given integral equation. Yep. Correct. Is it okay? This is a simple question. We will be solving one of the previous year question also. So the only thing that we need to learn is कि what are the Laplace of the basic transformation और उसका ही inverse निकालने को आना चाहिए. If you are comfortable with it, question would be simple. Is it okay? This solution is fine to everybody? Okay. So let's see a previous year question like this. So as I said, they directly asked this in I think 18 में पूछा और I think 19 में भी पूछा था. कोई तो एक अल्टरनेटिव ईयर उन्होंने पूछा था, दोनों साथ इंटीग्रल इक्वेशन बाय यूजिंग लैप्लास ट्रांसफॉर्म. सो बहुत ही इजी बनाने की कोशिश करेंगे. सो दिस इज नथिंग बाय माय h of t and this represent my g of t. So answer, whatever is my answer, is nothing but Laplace inverse of capital G of s. What would be the Laplace of this function e raised to minus t? उसका Laplace क्या होगा? What we know is the formulas that I required I will keep writing because I formula याद रखना थोड़ा difficult है. I feel कि जब examination उसके पहले at least याद होना चाहिए. अगर उससे तब तक याद नहीं हो रहा है तो problem होगा. So it is, if I have e raised to at, the Laplace is nothing but 1 by s minus, right? So here on the place of a, I have minus 1. So the numerator is nothing but h of s divided by 1 minus lambda g of s. So that is nothing but Laplace inverse my h of t, that is e raised to minus t. The Laplace is nothing but 1 by s plus 1. Is it okay? सही चल रहे हम लोग? Divided by 1 minus the value of lambda over here is 1, right? So it is 1 g of s, uh, that is nothing but the Laplace of sine. The Laplace of sine, again I'll just note it over here. The Laplace of sine at was nothing but a upon s square plus a square, right? Over here I have sine t. My function is sine t. So the Laplace would be 1 divided by s square plus 1 converted to variable t. So we need to find out the Laplace inverse of this. To find it, we just simplify this function. That is nothing but Laplace inverse of 1 by s plus 1 whole thing divided by s square plus 1 minus 1 whole thing divided by s square plus 1. This is t, hence this is same as Laplace inverse of 1 by, this becomes in the numerator, so I'll write it like this. Sorry. Okay. So it is s square plus 1 divided by s plus 1 times s square converted to variable t. Now the question arise, हम लोग ने जितने भी स्टैंडर्ड फंक्शन किए थे उसमें से किसी का भी डायरेक्ट लैप्लास ये नहीं होता है डेफिनेटली. सो वन ऑफ द थिंग इज कि हाउ वी शुड सॉल्व दिस क्वेश्चन, राइट? बिकॉज एक चीज होता है कि हम लोग इसको फ्रैक्शन में डिवाइड कर दें, दूसरी चीज होगी वी शुड यूज द ऑप्शंस दैट इज देयर विद अस, राइट? सो व्हाट आई डू, आई जस्ट वेट फॉर सम टाइम. We from the option just guess which of the function would have its Laplace like this. ऐसा कौन सा फंक्शन है जिसका लैप्लास ये होगा? अदरवाइज डायरेक्टली इनवर्स निकालने के लिए वी नीड टू फाइंड आउट फ्रैक्शन. द बेटर इज जस्ट फ्रॉम द ऑप्शन यूज वन ऑफ द फंक्शन जिसका लैप्लास ये होने वाला है. Because functions are very standard, it could be done. I'll just give you 1 minute. Then I'll just start discussing ki options jo hai, it could be either C or D. That is something that I wanted to point out. Because if we see easily, if I ask you what is Laplace of e raised to minus 2t, then the Laplace would have 1 upon s plus 2 inside it. So the first and second goes out. So only left is either it could be C or it could be D, right? So from C and D, we have to choose one of them. So let us just go for the C. Suppose if I want to find out the Laplace of e raised to minus t plus 2t minus 1. So e raised to minus t, the Laplace is 1 divided by s plus 1 plus 2 times Laplace of 1 is 1 by s square and Laplace of minus 1 is 1 by s. And if I just simplify this, this becomes s square s plus 1 common denominator. So over here I will have s square plus 2 times s plus 1 minus s times s plus 1. If I simplify this, the numerator becomes s square plus 2s plus 2 minus s square minus s. Whole thing is divided by s square s plus 1. So what I observe, this is getting cancelled out. Hence s square nahi hai numerator mein. So C also cannot be the correct choice. Hence the correct answer is D. Also, you can find out why D is the correct answer. Uska Laplace will match with this. So this is 2018 MHSET question. They have asked to find out solution of the integral equation by using Laplace transform. Right? So it is a kind of a big question. So whenever we attempt the paper, we should know which are my topic. Like whenever I attempt a paper, I always see, I read the question, is it something from my topic? Then only I touch the question, otherwise I leave it. But in MHSET, since there is no negative IP, at the end I take every options. But I solve only those questions which are from my domain. Otherwise I don't touch them. So if I touch, I need to solve it. If it takes time, that is fine. Yes, just go through the solution once. If anywhere, if you have any doubt, please ask. If it is clear, just let me know why in the chat box so I can go ahead. Okay. Okay. So I just go for the next question from the 2017 paper. Okay. So read the question. I will not say anything. I think the answer will come automatically. Right. They have given an equation to you and they are just asking what is the type of the equation. So this is the beauty of the examination. The same question was, some previous question was lengthy, but this question takes only few seconds. So the time can be managed if you take more time in one problem, other problem you can save. So the correct answer would be, the given integral equation is, it is A, right? So it is a linear Voltaro linear equation of second kind. Also over here, this is nothing but convolution, so it is convolution theorem, right? So this was nothing but the easy problem. Let's see 2016. So ma'am, this is one of the question which has been continuously asked for 4 years. Means what they used to do is they used to change this number. I think 2016, 17, 18 or 15 maybe same question. What is summation of phi of d? Right? So whenever someone covers number theory, they should definitely cover this question. But for now, I will just give the result. This result is like summation of phi d, where d divides n, answer is always equal to n. And this result could be proved in multiple ways. One of the proof that I have is I use factorization of x raised to n minus 1 into irreducible factors. So it is some kind of an algebra and number theory that I use to prove this. But this is wonderful result. The correct option is C. Right? But this question they have asked multiple years, so I just thought to I will share with TY students. But this is a wonderful question. Right? In 2016, one of the easy question. I'll just keep it on screen for some time. Let me know the correct answer in the chat box. Okay. Okay, so the correct answer is D, and I would request those who are going to appear, the convolution is something which is their favorite, because in many years they are asking some question related to convolution. एक ही question को तोड़ मरोड़ के they are giving every year, right? So is it okay? D is the correct answer, everybody. This is the convolution theorem. Yes, okay. Okay, so this is one of the homework question that I'm keeping because it is an integral equation. I just share the PDF. That time you can see the question, but it is exactly the same question. But as you see, integral equation takes some time to cover. So I just thought one I will solve, one I will give as an exercise. You can solve it in the way you want. Half question solve करके फिर option को use करना, that is always better, right? Because directly फिर Laplace निकालना might take some time. Laplace inverse निकालना, right? So it is finding an integral equation. Same चीजें करनी है. यहाँ पे ये है आपका h of t. We here the value of lambda has been -2. So please be careful. This is nothing but your g of t, right? So it is similar question could be solved using the similar method. Okay. Okay. So just let me know the answer for this. This is बहुत ज़्यादा recent है ये तो. I think 2020. I also gave this paper. So the Laplace transform of this is बेसल फंक्शन का सिर्फ और सिर्फ उन्होंने लैपलास पूछा है. सो दिस इज आल्सो फ्यू सेकंड में सॉल्व होने वाला क्वेश्चन. व्हाट इज लैपलास ट्रांसफॉर्म ऑफ बेसल फंक्शन? यस विच यस इट इज बी, राइट? डायरेक्ट फॉर्मूला था हमारे पास. सो दिस इज व्हाई आई इंट्रोड्यूस बेसल फंक्शन बिकॉज दे आर आल्सो इंटरेस्टेड. Okay, again the similar kind of question. The correct key is So if you solve previous year papers, you can sometime guess the आने वाले questions क्या होने वाला है, right? So convolution पे question आने वाला है, properties पे questions आने वाला है, कोई तो basic सी चीज दे दी है, उसका लाप्लास ढूंढने को भी आने वाला है, जैसे कि बेसल का उन्होंने पूछ लिया, right? So previous year papers are always important. Yes. So the correct answer is the Laplace of f of t is f of s, Laplace of g of t is g of s. Then what is Laplace inverse of f of s, g of s? Yes, anybody? Sure. Okay. District ones. The correct answer is हाँ जी, anybody? जागते रहेंगे. Yes, it is. मैंने slide change किया है. Okay, I think screen freeze हो गया क्या? Okay, I thought कि I have changed. I have changed the slide. It is showing change over here, but might not be there. What? हाँ हाँ. अच्छा. Okay okay okay. My change.
I cannot see the
Yes
same
yes.
previous question I can see.
Okay okay. What I'll do, I'll just stop sharing and I'll share it again. It might be some error. Okay. Because I was changing. I was with question of convolution which has been asked in previous year. Code model भी पूछा था. Entire screen. Okay. Yep. So now it is showing. This is from current slide. Yes. So this is 2020 question. Same year. Now it is showing correct. Yes, yes, yes. So the correct key should be A. It was right. A same ही question है लेकिन उसको थोड़ा अलग तरीके से लिखा गया. Just a convolution theorem again. Right. So I think this is an extra question जो मुझे TY वालों को देना था टाइम पास के लिए, but it is fine. नंबर 3 का था. So I think with this we have covered previous year के Laplace transformation के ऊपर questions. So whatever was there given in the portion we have covered well, and previous year question भी उतना करने से solve हो जाते easily. Now we come to the second part, that is nothing but Fourier transform. Before starting Fourier transform जो Laplace transform है उससे ज्यादा डीप है, यानी कि उसके अंदर बहुत ज्यादा चीजें हैं, फॉर्मूलाज इतने सारे हैं, कन्वोल्यूशन थ्योरम वहां पर भी आता है, स्टैंडर्ड फंक्शन के ऊपर भी होगी, प्रॉपर्टीज भी होगी, बट हमारा जो पोर्शन है वो फूरियर ट्रांसफॉर्मेशन को इतना वेटेज नहीं देता है. सो आई हैव ट्राई टू कवर द बेसिक डेफिनेशन, बेसिक फंक्शन, प्रॉपर्टीज and some application. So these are the things that we are going to cover which is given in the portion, but Fourier transformation बहुत बड़ा है, ठीक है. So I can say even more thing that Fourier transformation से ही बाकी सारे transformation आप origin कर सकते हो, right? So what we are going to do the Fourier transformation, if I have a function f of x, then the Fourier transformation would be denoted by capital F of k, where k is some real number. So here जैसे ही क्वेश्चन रीड किया जाता है दो चीजें स्ट्राइक हुई है. पहली चीज तो Fourier transformation is applied on a real value function and the output is also a real value function, whereas in the Laplace what we used to see that s was a complex number such that real of s was greater than 0. But here the output is also a real value function where k is the variable that we are using. So how to find out the Fourier of any function? The formula is given by 1 upon root 2 pi integrating from minus infinity to infinity e raised to minus I k x f of k dx. We here this is nothing but our kernel for Fourier transform. There are two small sub branches of this topic, that is nothing but Fourier cosine transform and Fourier sine transform. That is also interesting thing, and they are also interested in it because questions has been asked on it, right? So this is nothing but the definition that we will need. So I request all of you to just note down the definition. Once you are done, do let me know in the chat box. Fourier transform of any real value function. 1 upon root 2 pi integrating minus infinity to infinity e raised to minus ikx f of x dx. Okay, so I just go for the next slide. Whenever we see any transform, definitely since we have done the Laplace, we know there would be a question of inverse. In this case, the inverse is more easy. The inverse of Fourier is more easy since the formula is exactly same as a formula of Fourier transform. The only difference is of the sign. So the Fourier inverse, we have the kernel like this. This is nothing but our kernel. So it is nothing but e raised to ikx, whereas to find out the Fourier we use e raised to minus ikx. Definitely the variable in the integration has also changed. Over there we have integrating with respect to x, over here it is with respect to k. Right? So this is nothing but formula for inverse of Fourier transform. By this, their inverse and its Fourier transform, they are actually too much connected with each other. So there is wonderful property of the Fourier which is not satisfied by Laplace, but it is satisfied by Fourier. We are going to discuss it. But for now, I just request note down the definition of Fourier inverse. Yep, okay. So what we do, basic functions, we take a standard function and try to find out the Fourier of it. Definitely we won't go for sine and all functions. There are only two basic functions of which Fourier is to be calculated for examination, or I will say even after MSc also. These are the two basic functions that we are going to discuss. One of it is e raised to minus ax square. If I see any reference book on integral transform, this function and one more function is there that I am going to discuss. These are nothing but two standard functions on which the Fourier has been calculated. And the Fourier of these functions are also interesting. So the questions could be created on them easily. So we'll be discussing Fourier of this. So what I know is, I know that Fourier of e raised to minus ax square in the variable k, converted to the variable k, is given by the formula 1 by root 2 pi integrating minus infinity to infinity e raised to minus ikx, then the function is e raised to minus ax square dx, right? So we need to calculate this. What I do, I can just write this is same as 1 upon root 2 pi integrating minus infinity to infinity e raised to, what I can write is, it is nothing but minus ikx minus ax square dx. Okay, so now I need to find out integration of this. Now comes the difficult part. To calculate this integration, what I do, I just try to simplify the power of it. So I consider the power, I simplify it, and then I'll write it over here. Okay, so consider the power, that is nothing but minus ikx minus ax square. The first thing that I do is I take common minus a from it. If I consider minus a common, then it is nothing but x square plus ikx by a, right? And after this, what is my aim? Definitely I just tell you what is my aim. I want to write it as square of something. I want to write this thing as square of something. So over here I have x square plus something like ikx by a. So I'm trying to make the formula of a plus b whole square. So this is nothing but a square plus I have 2ab. So I want 2ab, so it is 2, I multiply, 2 I divide. So this is nothing but 2ab. I want b square. So what is my b actually? My b is nothing but this. This much part is b. So I add b square. To balance it, I just subtract it. So it is ik by 2a whole square. So let us just write it properly. So this becomes minus a. This first three together becomes x plus ik by 2a whole square. This thing becomes plus k square by 4a square. That is same as minus a times x plus ik by 2a whole square minus k square by 4a. So what we did, we just simplified our power of e. The ultimate aim was to write it as square of something. So we just able to write that as this thing, right? So in the next step, what I will be doing, I will be just replacing this power by something that I got. Is we are finding the Fourier transform. Acha, I should have wrote in the same slide. या फिर यहाँ पे लिखता हूँ, then I'll change. So it is nothing but Fourier of e raised to minus ax square converted to variable k. We had it as 1 upon root 2 pi integrating minus infinity to infinity. Then it was e raised to some power. That power is now same as minus a x plus ik by 2a whole square minus k square by 4a, and it is integrating with respect to x. So that is same as 1 root 2 pi. I can take this out, so it is e raised to minus k square by 4a outside, integrating minus infinity to infinity, e raised to minus ay square dy, where my y is equal to x plus ik by 2a is our substitution, right? So we have used a substitution of y is equal to x plus 2a, right? So after that, what we got is this. Now comes a part where I have to skip something. The part that I'm skipping for now is the value of this, and the value of this integration is actually root pi by a. And this is one of the interesting integration. Everybody who is appearing for the examination, they should first know the value, and the second thing, they should know why this value is obtained, means what, how the value is obtained, right? So for now I will be using this value directly because the proof will take much more time. So I will directly using the value of that integration is root pi by a, right? So if I use that value, the answer is my root. Okay, so it is pi by a. So root that cancels, so it is 1 by root 2. Root pi cancels, so it is 2a e raised to minus k square by 4a. Right, so ultimately, finally, we able to find out the Fourier of e raised to minus ax square converted to variable k. So this is one of the reason why we don't find out the Fourier of sine and cos all such functions, because it takes too much time. Even this will take more than half an hour if we try to find out the value of integration. But for the examination, the most important thing is to know what is the Fourier of e raised to minus ax square. Right? So the answer is nothing but 1 upon root 2 pi e raised to minus k square upon 4a. Now there might be a question why this is so much interesting, because what could be done in the examination, they can. Yes ma'am, yes. कहाँ पे मैम? यहाँ पर मैम, हाँ मैम पाई था, लेकिन ये जो इंटीग्रेशन का वैल्यू है ना, व्हाट आई डिड इज यहाँ पे पाई लिखूंगा, है ना मैम, इस तरीके से, तो पाई पाई कैंसिल होगा एंड देन रूट ए यहाँ पर, ठीक है ना मैम?
Yes, yes, मैं थोड़ा मिस किया इधर लिटिल बिट आई सॉ
Okay, ma'am. So why this is interesting is because what they can do is they can give a different values of a and the question could be changed. I think 2 साल ऐसे थे जिसके ऊपर इसके ऊपर क्वेश्चन थे by just changing the value of a, right? So but the most interesting thing is, suppose if I consider my a is equal to half, something beautiful happens in this. Suppose if I consider a is equal to half, I get Fourier of e raised to minus x square by 2 converted to variable k is same as 1 by root of 2 times half, that becomes 1. So it is equal to e raised to minus k square 4 times half, that is only 2. So this is special. Whenever we consider a is equal to half, the function जो है that becomes e raised to minus x square by 2 and the Fourier is exactly itself. So whenever this is the formula that I'll write, if I consider a equal to this, such a function is called self-reciprocal under the Fourier transformation. Means if I apply the Fourier, I get the same thing. If I take a reciprocal, I get the same thing. The only thing that changes nothing but the variable, right? So please note down the formula. Proof I will give while sharing the slide. I'll just change this. जो पीछे background में दिख रहा है ना वो नहीं दिखेगा, बस proof आपको मिल जाएगा. But this formula is important, so just make a list of this. And the special case is also important. I think previous to previous कोई तो एक साल में पूछा गया था. I don't remember the year, but कोई तो एक year था जब ये पूछा गया था. I think नेट में हो सकता है शायद से, right? So this is nothing but the answer. एक बार नोट करेंगे और मुझे चेक बॉक्स में बताएंगे if it is okay or not. Yep. Okay. So just go for the next function, standard function. इसके बारे में हमें बात करना है. So I want to find out the Fourier of this. This is easy. Fourier of e raised to minus a mod x converted to variable k. This is given by 1 upon root 2 pi integrating from minus infinity to infinity e raised to minus a mod x, and the kernel to find out the Fourier is nothing but e raised to minus I k x integrating with respect to x. So since I have a mod, I try to divide the integration into two halves. So it is equal to 1 upon root 2 pi outside from 0 to infinity. Mod x is same as x. So I can write this is same as e raised to minus ax minus ikx dx plus integrating minus infinity to 0. So from minus infinity to 0, the mod of x is minus 6. So this becomes ax minus ikx dx. So it is 1 upon root 2 pi. If I integrate this, this becomes, okay, I just simplified one more step. So it is e raised to x minus x, I write e raised to minus x, a plus ik dx plus integrating minus infinity to 0, e raised to x, it will become a minus ik dx. Now we just have to find out integration. The integration of e, everybody of us knows it, right? So can I just directly write the integration would be 1 upon a plus ik in this case, and in the other case it would be a minus ik. I just give you few seconds to analyze why this answer came. Just go through it once. Yes. Okay. We can further simplify this. If you integrate the first part, it is 1 upon a plus ik. If you integrate the second part, it is nothing but 1 upon a minus ik. Just integrating it, substituting the limit. So at the end, I get 1 upon root 2 pi. This is nothing but, if I just simplify, this is nothing but a minus ik plus ik cancel. So it is 2a divided by a square plus k square. So this root 2 cancel with this. So finally what I get is the answer is root 2 by pi a upon a square plus k square. This is one of the important example in the Fourier because it somewhere connects the Laplace with it, right? If you अब थोड़ा याद करोगे, there was one of the function जिसका Laplace कुछ ऐसा ही दिखता था, right? Sin t, sin 80 and cos 80. The Laplace was something similar. So there could be some question based on the relation between Fourier and Laplace. 2020 में आई थिंक एक क्वेश्चन था जहां पे उन्होंने लैपलास और फूरियर का कनेक्शन पूछा था, आई थिंक 2020 और 21, राइट? सो दिस इज नथिंग बट द सेकंड स्टैंडर्ड फंक्शन जिसका फूरियर आपको पता होना चाहिए, राइट? सो फूरियर ऑफ e रेज टू माइनस a mod x is nothing but root 2 by pi into a upon a square plus k square. Just go through the proof once. If you have any doubt, difficulty, let me know. Otherwise, let me know why in the chat box. Okay, so it is fine. So with this two function, actually we can solve few of the previous year question. What was my plan is to go for properties of Fourier, but I feel properties we can see slowly with the questions. So I have kept many slides so you can see there are many properties that we were supposed to discuss. From this many property I want to discuss, but I feel few of the previous year question would be more interesting to solve, right? With the last 10 minutes that we have, we can discuss few of the problems, right? So this is an interesting question. They have asked us to find out the Fourier of f of t cos 80. So while solving this problem, we can learn one of the property, that is modulation property of the Fourier. What they have told me, that they have told me my Fourier of f of t converted to variable s. What the variable they are using? Now I will be using the same variable. F of t is given by capital S. They have used delta S. I will be using capital F of S. Okay. So now they are asking me to find out the Fourier of f of t cos 80. So what I'm just trying to tell you is, in this while solving this problem, suppose if you don't know the property, still you can prove this property easily. The only thing that we should remember is the basic definition of Fourier transform. Okay, so I need to find out, so I just write the formula. It is 1 upon root 2 pi integrating from minus infinity to infinity. The kernel I will write e raised to minus I k x. On the place of x, now we have variable t, so I use t. Then it is f of t cos 80. Okay, so I just pause for a few seconds. Let you guys think what should be the way to find out this integration. What I should do. Suppose if I start thinking about integrating, how I can integrate. UV rule, definitely ma'am, if we start thinking about UV rule, I have UVW. Also with that I have one of the function which is cos 80, यानी कि वो repeat होते रहेगा, उसके साथ साथ f of t that would keep on troubling us, right? f of t के बारे में नहीं पता है, so अगर मैंने UV rule लगाया तो I will have three things, उसका फिर निकालो, that will take time. Anything else that I can see? Why this question was asked? It is, अगर किसी ने property नहीं किया ना तो भी वो कर सकता है. The only thing is
Of t or e raised to I k t together.
Okay.
And to cos it is.
Right. So if we just take that u into v, then मैम still ये cos 80 है ना, उसका डेरिवेटिव लेने के वापस से हमको तो sin 80 मिलेगा. So that means cos से sin, sin से cos घूमते रहना पड़ेगा. So the thing that we can see is my cos 80 can be written as a power of e. Because I have e with me, and you can see this is same as actually s, right? So I should use s over here. This is f of s. This is f of s ना, यहाँ पे s था इसलिए मैंने k की जगह पे s लिखा है. What I see is this cos at can be written as power of e. So I just try to use it. ist cos at I write it as e raised to iat plus e raised to minus iat divided by 2 f of t dt. So this is same as what? This is same as 1 upon root 2 pi integrating minus infinity to infinity, that half is there. With that half I have e raised to minus I t I take outside, inside the bracket once I will have s minus a, that is multiplied with f of t plus e raised to minus it I take outside, inside the bracket I will have s plus a, which is multiplied with f of t, and the whole thing dt. The advantage is what I see, I can take the half outside. First thing I write 1 upon root 2 pi integrating minus infinity to infinity e raised to minus it s minus a f of t dt plus 1 upon root 2 pi integrating minus infinity to infinity. The second time I have e raised to minus it s plus a f of t dt. So if we see carefully, we can easily observe the first part is nothing but the Fourier of f of t. Yes or no? The first part is nothing but Fourier of f of t, but the only change is the variable. Now the variable has become s minus a. So I'll write this is the same answer, but the variable has changed to s minus a. Is it okay? Everybody should be able to observe this. अगर नहीं हो पा रहा है, then I'll try to dictate it again. Okay, that is fine, ma'am. It is fine. What about other? Is it okay? Everybody is fine with this? Just go through it once. This is nothing but proof of one of the property. In the examination, no one is supposed to prove it. But since I haven't discussed the proof of the property, so I thought I'll discuss with the one of the problem. Yes. What about other? Mandar, is it okay? Can I write this is same as Fourier of the same function, but the variable is now s minus a, because this was actually 1 upon root 2 pi integrating minus infinity to infinity e raised to minus ist f of t dt. Right? So if I see s over here, it is capital F of s. Now it is the same thing. The difference is s is replaced by s minus a. Between I have plus, and at the end I have f of s. Over here the variable is s plus a. Right? So from the given options, option C is correct. Right? So this is nothing but one of the property of the Fourier transform. So we can again and again, we are just observing the same thing. MHSET examination, they don't want to trouble us. They are asking just the standard things about any topic. Right? So what they ask, Fourier transform. So they ask the property of it, direct property, nothing else. Is it okay? Just go through it. I'll just keep this on the screen for some time. Just go through the proof once. If you have any doubt, difficulty, do let me know. If it is okay, the slide is okay, do let me know why in the chat box, so I can go ahead with my next question. Okay. So if this is asked, definitely we can expect the next year question could be f of t sin 80. Okay. So this is also one of the property, but for now I just keep this as an exercise for all of you. Right? You should just try. Even without trying, you can guess the answer. Right? The only thing that was cos 80 was written in terms of e, with your sin 80 would be written in terms of t. You will get the similar answer. But be careful about the sign of order. Right? जो भी order में sign आएगा वही order में लिखना है. Preksha ji, if you see carefully, sin 80 we have I in the denominator, so it is 2I. Correct. This is something that I said, right? Suppose if I just tell you the answer would be 1 upon 2I. Now it would be in the same order, but the minus sign. So it is f of s minus a minus f of s plus. This would be your answer. है ना प्रेक्षा जी, just go through it once. कैसे मैंने ये आंसर लिखा, you can think of it, right? Because sin 80 को लिखो in the head. Proof is exactly same. The places where it changes to 2i, right? The order is also same, and in between I have minus, right? So this is an exercise, could be done. So now what I'll do is I'll just try to recall the things that we have done today, right? So what we started today, we started with solving the integral equations. The integral equations of the particular type, the type is called as a convolution integral equation. Of the type, f of t was same as h of t plus lambda times integrating 0 to t, f of t minus tau, I can write t minus tau g of tau d tau, right? So the answer for this by using Laplace was nothing but, solution was nothing but Laplace inverse of h of s divided by 1 minus lambda times g of s. Right? So this is something that we started in the Laplace transform. With this we conclude